One ignition and liftoff of SOHO and the Atlas vehicle on an international mission of solar physics.
Roll program is in. Vehicle responses look good at this time.
Listening now to Skip Mackey in central telemetry here at the Mission Director
All engines
Center.
look good. Solids burning well. Atlas PU is active. Solids look good. All engines look good.
Hi, I'm Joe Gurman. I'm a solar physicist in the Heliophysics Division at NASA's Goddard Space Flight Center. All of the 8 large planets in the solar system orbit the Sun in a plane that lies within a few degrees of the Earth's orbital plane, the so-called ecliptic. So when we observe the Sun with a coronagraph that blocks the much brighter light from the Sun itself so we can see the faint corona, the Sun's hot outermost atmosphere, we get occasional glimpses of planets. And in this remarkable series of images, we actually get to see several different planets, and also in the upper left of the image you can see the Pleiades, the star cluster. The images of the planets come out here looking as though they have horizontal streaks because they're so bright that they overwhelm the electronics in the detector that's taking this image. SOHO's Extreme Ultraviolet Telescope allows us to see a variety of solar activity, and some of the most intense activity we saw was in the fall of 2003, which was a bit of a surprise because it was a couple of years after the maximum of the 11-year solar activity cycle. It's a beautiful clip, and it shows what SOHO's Extreme Ultraviolet Telescope can do. So what we're seeing here is those same periods of activity in the fall of 2003, only this time from SOHO's coronagraph. And you can see a sequence of events, so-called coronal mass ejections, launching off in all directions as the active region rotates across the solar surface. And you also see what looks like snow on the windshield of a car driving through a blizzard, and that's energetic particles accelerated by the solar activity hitting the detectors on the SOHO spacecraft. Prominences are cooler gas that flows along magnetic fields in the much hotter solar corona. And in this image from 1999, you can see the eruption of a huge prominence from a fairly high latitude in the Sun, and that tells us that it's associated with new cycle magnetic fields and with the expulsion of twists in magnetic fields from the old solar cycle. Each of those approximately 11-year halves of the magnetic cycle displays its own cycle of first increasing and then decreasing magnetic activity. And that's reflected in the intensity of extreme ultraviolet emission from gas that's trapped in the magnetic field. So in this image you can see a series of snapshots taken one a year over a solar cycle. Over the course of the SOHO mission, we've observed over 3,000 sun-grazing comets that come so close to the Sun that you can't see them from the Earth because the Sun basically blinds Earthbound telescopes. With SOHO's coronagraphs, we're able to track the comets all the way into their evaporation near the Sun. In late 2012, astronomers discovered a comet inbound. We didn't know if it would survive its passage with the Sun or not, and we were able to get these measurements with SOHO's C3 coronagraph of the comet as it passed in towards the Sun, and then a ghostly image of the comet continued past the Sun, but it was already evaporating. If you're able to catch it, and if you blink you'll miss it, you see a wave traveling outwards from the flare in the lower solar corona. What EIT was really good at, and in fact discovered, was these waves in the very lowest part of the corona that corresponded to coronal mass ejections, and we literally hadn't known about that before. In a coronagraph, you don't know if an event is headed towards you or away from you. The geometry is the same. And with the addition of an extreme ultraviolet image that shows a wave like this, then you know that the event has occurred on the earthward side of the Sun, and we may very well have some space weather in store in 1 to 3 days. This clip shows Comet Mach-Holtz, which SOHO observed in 2002 as it was passing near the Sun. And as the clip shows, the direction of the comet's tail, which is made up of electrically charged particles, changes as it passes the Sun. That's because the Sun's solar wind a continual emission of plasma from the sun is pushing it outwards. This shows an entire solar rotation of about 28 days in 2001 as we were ascending up to solar maximum. And you'll see several events in here. And the interesting thing about these is how they're distributed in latitude. You know, they're not all just along the horizontal axis in this series of images. And that's an indication that you are reaching solar maximum. During solar minimum, the much smaller number of events that happen all seem to come off the east or west edges of the sun. But as you get towards solar maximum, the active regions are distributed all over in latitude, and you get this much more active appearance.
I hope you've learned a little about SOHO Lasco and are keen to find out how to use the instrumentation so you're not reliant on other people. It is important to know that you do not rely on channels such as World News Report Today, as its presenter has proved he is incapable of getting even basic facts right. i.e., he has described C2 and C3 as being different satellites. They are not. Lasco coronagraphs C1, C2 and C3 are part of the Lasco instrumentation aboard the SOHO spacecraft. He cannot correctly identify objects that pass through the instrument field of view, which is a severe indictment of his capabilities to educate people in space weather. In part 3, we shall look at his mistakes and you will be shown how to fact check what he tells you. Till then, stay safe. Bye for now.